Okay, let's continue with slide 8. And so looking at the general anatomy of synovial joints, where we have a joint capsule that's surrounded by a synovial membrane, has synovial fluid in there, and there are articular discs, that is hyaline cartilage that lines the synovial cavity. Sometimes there are other things called menisces, which are little bundles of fluid. Some synovial joints have that, tendons, ligaments, bursa, which are little sacs of fluid that surround ligaments, and tendon sheaths. Okay, now exercise is really important to keep synovial joints healthy. For one thing, cartilage is non-vascular. Um, so moving helps to move oxygen in, carbon dioxide out, move waste out, move nutrients in. It helps to keep synovial fluid really thin, and it also helps to stabilize. It helps to strengthen the muscles that in some joints actually helps to stabilize the joint. So joints are another thing that you use them or lose them. You don't move a joint, it will eventually completely seize up on you. Slide 9, here's a drawing of a typical synovial joint and the parts. The periosteum on the outside of the bone, yellow bone marrow. There's articular capsule, um, fibrous layer, synovial membrane. This is the case of a membrane that has no epithelium. It's just connective tissue. Here's a joint cavity with synovial fluid inside of it. The articular cartilages, which I think are usually um, um, hyaline, and there's a ligament. Remember, ligaments attach bone to bone. Most ligaments are external. We're going to see a couple of ligaments that are actually internal. Okay, in synovial membranes, the range of motion is sometimes limited by certain things. Sometimes it's the structure of the bones in the joint. Sometimes it's the tautness of ligaments and joint capsules, and also the number of muscles and tendons and tendon sheaths and bursa around it can limit the range of motion. And we have axes of rotation, degrees of freedom, which means how many different directions can this joint move. If it can only move in one direction, it's called monaxial. If it can move in two directions, it's biaxial, and if it can move in really lots of different directions, it's called multiaxial. Okay, on slide 11, you're going to need to know particular synovial joints and what type they are. One is called a ball socket. These are the only really multiaxial joints, and they are the most freely movable of all joints. And shoulder is the most movable and the least stable. And it's really held in place by muscles. So it's the easiest joint in your body to dislocate. Then there's something called condylar, which is just these two convex surfaces, the curved surfaces, the metacarpal phalangeal joint, which is a long way of saying the one between your fingers and your hand. That's a biaxial. You can move it forward and backwards, and you can do the Spock sign to one side. Saddle joint, trapeziometacarpal, another fancy word for saying a thumb joint. That's also biaxial. And then in the bones that make up your wrist, the carpals, and the bones that make up your ankles, the tarsals, these are plane. They're just two like flat surfaces that move against each other, and they're really considered biaxial joints. Okay, now moving on to slide 12, still more class of synovial joints, hinge joints, elbow and knees, and these are monaxial. They only move in one direction. And then there's pivot ones, where you can, one bone moves in circular motion around the other one. Radial ulnar is is that it allows you to rotate your hand from palm up to palm down. And the axial joint, which is between your skull and the first vertebrae, and allows you to rotate your head. That's called axial. It's a pivot. And then there's a couple of joints that are really sort of complex. One is the temporomandibular, which is your mandible and your temporal bone. It's both a hinge joint, I think a plane joint, and I think a condylar joint. I mean, it's three different ones. It's really complex. And knee, you got to be careful here. I put knee in combinations, but it really should be kept in hinge. It's almost completely a hinge joint. It's a slight pivot movement on it. So you consider it a combination. But if you going to want to classify the knee, you really should keep it in hinge. So you'll be asked about, what's the example of a hinge or a pivot or plane or whatever type of. Give me an example of a synovial joint in these categories, in these classes. Okay, slide 13. Here's examples of all the ones we just talked about. Plane joints between the carpals in your wrist, a hinge joint like your elbow, ball and socket like your hip, a pivot joint where, as I mentioned, this allows you to rotate your head, condylar joint between the metacarpals here and the carpals, and then here the saddle joint right here between the trapezium bone and your first metacarpal, which is your thumb.